All right, ready? Folks, a ship maneuvers to within 2,500 meters of an island. So right away, here's the ship. Here's the island. This is 2,500 meters. Written as 2.5 times 10 to the third. I'm writing it as 2,500 meters. Of an island's 1.8 times 10 to the third meter high mountain peak. So the mountain looks like this now. And we're told that it's 1.8 times 10 to the third, which is 1,800 meters. Okay, that's what we've got so far. Does that make sense? Okay, when you draw it, think about where the center of the object is. Now we're told that it fires a projectile at an enemy ship 6.1 times 10 to the 2 meters on the other side. So we draw another dot on the other side, out here, and that is 610 meters. Next, if the ship shoots the projectile with an initial velocity of 2.5 times 10 to the second, what's that? 2.5 times 10 to the second? 250? Good. And an angle of 75 degrees. Bless you. So theta is 75. How close to the enemy ship does the projectile land? How close does the projectile come to the peak? So what are we finding in essence? If we're trying to find how close to the ship it's going to land, we're finding the distance this projectile travels in the x direction. Then, if we're trying to find how close to the peak it comes, we're trying to find the y value, the height of the projectile, when x equals 2,500. At this location, we want to find where it is along the y-axis. If it is at a distance of 2,000 meters in height, when x equals 2,500, it means that it's pretty much right up here. It's just above the peak. 2,000 meters would be up here, because this is 1,800 meters. So we are trying to determine y when x is 2,500. Okay?
How do you know that x is 100?
Because the distance from the boat you're firing from to the island peak is given as 2,500 on the diagram.
When I did, I added 250 and 600 and then used that as my x.
No, that's your mysterious x. Remember the Tom Cruise where we covered up the x value?
Yeah.
That's what this is. Because if you can determine x for the entire flight, you can see how close it is to 3110. The total x in this problem that you're wondering about, okay, x equals question mark, is 3100 meters. The sum of those two distances, right? That's what you want your x to be for the first part. But for the second part, when you're finding how close it comes to hitting the peak of the mountain, you want to find the height when the projectile pauses on the path right here.
So you're going to find the highest point.
So you're finding the y value is not the highest point. The highest point would be the point of symmetry.
Okay.
Think about projectiles. The highest point on the path is right in the middle, right? Is 2,500 in the middle of 3,100? Oh, 3,110. Nobody corrected me. Of 3,110, 2,500 is not smack in the middle. So this is not y max. This is y at a height of, or at a distance away of 2,500. So let me redraw it to make it more clear. You would have something like this. It would reach its max halfway, which would be like here, okay? So we'll say it's going to reach max height right here. Then it starts to come back down. And we are looking at it at this location right here, okay? Which is the y value at x equals 2,500 meters. So it's like you're finding, think about a graph. If you wanted to find a coordinate, you would say like 2, 7 or 5, 3. Agreed? So here's your coordinate. Your coordinate is 2,500, question mark. You need to find question mark, which is the height of the projectile when x is 2,500. You're trying to find that coordinate right there. Now, if that coordinate is greater than 1,800, it passed the mountain. If it's less than 1,800, what happened? It hit the mountain and it's not going to hit the boat. Okay? Now, the other question becomes, If it does indeed clear the mountain, how close does it come to hitting the boat? That's why we're determining x, and then we're going to compare it to this distance. So if it's greater than 3110, it missed the boat on this side. If it's less than 3110, it missed it short. If it's 3110, what did it do? It nailed the boat, or hit the boat. Okay? Does that make sense, this kind of problem? So it's tricky because you have to ask yourself, what's going on? This would be a really challenging problem for the test. Like the hardest you would see for sure. If you ever had one of these, it would be like only one problem, and it wouldn't be worth more than like 5 points. Okay? Because it's a tough problem. But I put it on the problem sets so you have to think outside the box. And remember, the problem sets are only worth homework. So it's not going to affect your grade as much as the test. The problem set is really for you to really stretch your mind. Okay? It's not really for the grade. I grade it so it forces you to really think, and so you spend a lot of time on it. When I took physics in high school, as an 11th grader, I took AP Physics. We had honors physics, but you could place out of honors physics if you did well enough in math. So you started in AP Physics in 11th, and then you took another AP level course in 12th. And I remember the type of problems that really made me think were the ones like this. So this would be like a low-level AP problem on an AP exam. So it's definitely a tough problem. It's not easy, but I'm trying to do it, trying to give it to you so you really challenge yourself. Let's list our knowns. So what do we have here for this kind of a problem? And remember, this is not known for x. X we're trying to determine. So let's say x is our question mark for now, right? We'll first try to see where it lands with respect to the other boat. We'll get our x, and then we'll look at our y for the mountain. We'll do it in the order that the question asked. Usually the question asked it in that order because you want to determine the information in that order. You might use one piece in the next. So let's take a look at trying to see if it lands on the enemy boat. So what do we know in this problem? Give me some information in the x direction first. What is VIX? What is VIX?
250 times cosine 75.
Very good. Remember, VIX is whatever VI is, 250, times the cosine of the angle, which is 75. What else in the x direction? Do I know anything else? We could make a statement, but we're not going to write it. What's that statement? In the x direction, something is always 0. Acceleration is always 0. You know that? We don't know x. That's what we're trying to determine. We don't know time. So we'll leave it blank for now. We can write those as question marks.
Question?
Yeah.
What's the number next to
75 right here.
No, right above y.
Y,
Yeah,
610. It was 6.1 times 10 to the 2. Remember, Tristan, we're trying to find out x, and if x is the same number as this, we hit the ship. Remember the question is, how close to the ship will it come? It's the same question as, does Tom Cruise make the jump? You don't have x, you need to determine x, and then compare it to the number that's there to see if you indeed did hit the ship, or where it landed with respect to the ship, the relative position, how close. So you're not using that as x, you are determining x, and then comparing it to that number. Okay? Cool. All right. So what do we need to do to find this problem? To find x, we need to get time. So where do we look? What do we know in the y? What's the y value? For the entire flight, be careful. For the entire flight, what is the y value? I'll go to VIY in a moment. The important part is the y value. Come on, guys. The whole flight. The delta y. 0. Very good. You both saw it. You start on the ground, you launch the projectile, and you end on the ground. So in the y direction, what's your height initially? What's your height finally? What's 0 minus 0? 0. Good. 0. Okay, that's the key here. VIY. What is VIY? Yeah, same thing as the other direction, just put sine. Very good, Gio. Okay? I'm not being consistent with my parentheses. Sorry. Thanks, Gio. I forgot it was dressed down there. I just took my time off. True story. And I had a jacket, actually. All right. And last T. So in this problem, what can we find? Folks, what can we find? Time. Now, there's a little trick I want to show you. You don't need the quadratic formula or the calculator, even though t is unknown in 2 spots, because y is 0. Whenever y is 0, you're going to see that you can just factor something out. Let me show you what I mean. So let's write our equation here. This is really exciting stuff. I would be too. Alright, so here's our equation, right? Why is this our equation? Why is this our equation? Yeah, it's the variables we have, it's the equation for motion, it's what works. Now, what could we also have done, by the way? Think outside the box for a moment. Pause what you're doing and think about this. You could have used VF equals VI plus AT if you call VF 0 and find the time to max height. Remember at max height, VF is 0 in the y direction? You could have found the time to max height and done what with it? Doubled it. Just doubled it. Because the time to max height is half, so then it is double to get the full time, and then plug it where, Tori? Yeah, you can plug it into quadratic halfway to get the y value. You can plug it in over here. So if you don't want to go to the quadratic in this method, you could use VF equals VI plus 18, find the time to max height, double it, use that as your time for the whole problem. Okay? We're going to have to do that, or we're going to have to split our time in half in a moment to find the y value at max height. Because we're going to get the answer for time here. That value divided by 2 is the time to max height, which you're going to have to use in part B. So we're going to have to, in the end, still get the halfway time. But let's do this since we already started it. So we've got 0 equals. What does that come out to? Somebody give me a number, please. 250 sine 75. Quick.
241.5.
Why is this number very close to 250? Because the angle is very close to 90. It is launched mainly in the y direction. If it was launched at 90, the y would be 250 completely. It would be all in the y. But it's a little bit of an angle, so it's around 240 in the y. Just waving. All right, minus 4.905 t squared. Now, who was there yesterday when I did this? There were a few of you. Step me through what I should do. Let's see if you remember. Why did I factor t out? Yeah, take a look. There's no value here. So you don't have to add a number over here. So now every term has t in it. Look, term number 1, term number 2, both have a t in there. So factor the t out. Remember greatest common factor, GCF? That's what this is. Factor it out. Now, that lowers the exponent by 1 on all the t's. So this t is gone. It's just 241.5. And the other t is just t by itself. No more t squared. That's what I'm doing in essence, yes. But you do not ever do that math. You can't forget about the factor you take out. I'll explain in a moment. Hold on. Now, look on the side over here. Quick side note. If I had this, how would I solve it? That's an x plus for you. No, you don't FOIL this. Come on. That's not solving it. Solve for x. What do? Make a blank chart. What do you call it? Oh, jeez.
X minus zeros.
A factor chart. You should have learned this in Algebra 1. You didn't do anything with the quadratics in Algebra 1? Alright, so take a look. If this is the case, here's what you do. You set each factor equal to 0. Okay? Because think about it. How can you get 0 as a product? If I have 5 times 0, what's the answer? 0. But what about 0 times 5? So that means that either x minus 2 could be 0 or x plus 3 could be 0. Because these are factors, they're multipliers. So we have to set each of those expressions equal to 0 individually and solve the resulting equations. Well, all you get is x equals 2 and x equals negative 3. So do the same thing here. You've got 2 factors. The first factor is t, and that could be 0. And the second factor is 241.5 minus 4.905t, and that could also be 0. If either of those factors are 0, the product indeed is 0. So you set each of them equal to 0 and just solve the one on the right. Tristan, this is really important that we don't ignore this t equals 0. And I'll explain in a moment why. But that's the part you were talking about, okay? Solve on the right. Add 4.905t to the right side, and then divide by 4.905. So inherently getting 241.5 over 4.905. What do you get? What's your time for this problem, people?
241.5 divided by 4.905 equals 49.2.
Now, that's one answer. Here's the other answer right above it. Why is 0 an answer? How does that make any sense? When time equals 0, what has happened? Has any... Yeah, the object's not moving. It's at rest though. It hasn't even begun. Before I begin the race, that's time 0. As soon as I begin the race, I'm into the race, right? I'm at time equals at least 0.1 or 0.001 or 0.0001 or some value of time. Before the event happens, that's time equals 0. Luke, where am I before the event happens? I'm on the ground. So that's why this is one of my solutions. Because didn't we set y equal to 0? When is y equal to 0? When you're on the ground in the beginning and on the ground at the end. So you get two different answers for time. This corresponds to the value of the projectile being on the ground before launch. This corresponds to the time of the projectile when it hits the ground after it's landed. So you get 2 times. Which one are we using? Clearly the one when it lands. The one before it begins has no value to us. So even though it's there, we don't necessarily reject it for like negative time like we did last time. We say we need to use common sense. Okay? That makes sense? Now, that's the time for the whole flight. 49.2. Let's scroll back up. Let's fill that in the x direction. And let's find the x value. Everybody should be able to do this in like 2 seconds. Here, let me talk about a quick fun fact to help you on grades for tests. Okay? If for some reason you could not find the time in the y direction, hypothetically speaking, you couldn't get the time for the entire trip, you just couldn't figure out the answer, pick a number. Pick a number. 4 seconds. So he said, you know what, it took 4 seconds. Use that in the x direction. Show me that you can do the rest of the problem in the x direction. You'll get the credit for that half the problem. So if you make a mistake in part A and you can't figure it out, and you need part A to get to part B, pick a number for your answer and then use it in part B. And I'll check the math that you did it right in part B. Do you follow what I'm saying? And that's how you do this on AP exams. If you ever take an AP course and part B relates to part A, you just pick something for part A. And then on part B, you use your number you got for part A, and you'll get credit for part B. So you don't get double jeopardized. Because it's not fair to you, right? If because part A, you can't get part B. So you pick a number, and then use that number over here. Okay?
Yes, right.
If you guess right, obviously, you can get a point, but you're not going to get credit for the right work. If you don't have the right work. Right? Luke, I saw your hand pop up. No? Alright, so what do I do at this point to get X? What do I do to get X? Yeah, what did you say? Multiply, right?
Yeah.
Okay. Multiply by t. Alright? So plug in those numbers, you'll get your X value. Can somebody give me a number for that, please? 250 cosine 75 times 49.2. Make sure you close your parentheses after 75. Or else the 49.2 will be put in there. 250 cosine 75, close parentheses, times 49.2. Tori, you got something for me? Looks like you do.
I got 3,183.
Tori, I asked. I want to split it up. You're getting the other ones. I'm glad. I don't want others to contribute also. What do you got? 49.2. 3183.5. Agreed? So what happened? Did this projectile hit the island? Or did it hit the boat rather on the other side? 3183. What was our number up here? 3110, right? So what did it do? It cleared the mountain and it cleared the boat. It overshot the boat by a lot. What was our answer? I ran off the screen.
3183.
Yeah, 3183. So 3183, 3110, it missed it by 73.5 meters. That's far. That's a bad shot, right? If you're thinking about it. If you're in the military and you want to hit the boat. Now, what does it depend on? Go ahead.
What I was saying?
Yeah, because there's a point you want to make.
If we're talking about a big aircraft.
Exactly. If the aircraft carrier is, say, 1,000 meters long, which is only, 3,000 feet, that's not that long, this would strike it because it only cleared by 78.5 meters. You follow? So the fact that it missed by 80 meters seems like a lot, but the length of the aircraft carrier or whatever the boat was not taken into account. There's a new book that's out, or actually it's an old book, but it's coming out as a movie on November 3rd. It's called Ender's Game. Has anybody heard of it? Has anybody read the book? Have you read the book?
Yes, it's awful.
Okay, because you read it in what grade? 6th grade. Read it again. I'm only like halfway through the book. It's amazing. It's all about gifted children and how there's in the future wars in space where there's no gravity. Imagine there's no gravity. How do you fly a ship? You need thrusters on every side to move forward and back. There's nothing pulling you to the ground. There's no such thing as free falling anymore. If you're in the craft, you can't move, or gravity, you can float around and stuff. It's a crazy good book, but I agree. Listen, Luke, if I were in 6th grade, I'd be like, what is this? It doesn't make any sense. But if you think about it a little bit, the stuff that happens in the book, you know what they use this year? The reason I'm bringing it up is I'm going to talk about it. I'll probably show a clip from the movie when we get to momentum. Momentum is involving where you push off somebody, right? In football, momentum is tackling. If you run with the ball and somebody tries to tackle you, if their momentum is more than yours, you get tackled. That's it. That's all the laws of football that exist. Sure, you can make moves, but if my momentum is more than yours, you're going down, or vice versa. If yours is more than mine, you'll run through me. That's it. And it's weird to think about. But this whole book is about momentum. It's kind of cool. No. My friend is an English teacher in 11th grade, and his 11th graders are reading it right now. That's the book they have to read this year. He picks pretty cool books. He's a teacher out in Long Island at Comac. He's a smart guy and he knows a lot. All right, so let's keep going. So this is our answer. Now, what was the next part of the problem? To find what? If the projectile does what? If the projectile does what? What was the second part of the problem? If it clears the mountain, and if so, by how much? So we want to find, let's take a look, not the max height, but the y value when x is 2,500. Okay?
Is that like a proportion with the time?
Is it what?
Would be set a proportion with the time?
No, let's think about this. If I want the y value, here's what I'm going to use. Absolutely. So, here's your equation for y. Now, what's the other equation that involves y that we could try to use, but it wouldn't work too well? It's much better. Vf squared equals vi squared plus 2ay. Remember that equation? If you wanted to use that, you could try, but we don't know what Vf is, or the velocity when x is 2,500. We don't know it, so it's pointless to try that equation. Instead, we'll use this equation. What we need to do, though, we realize that we know VIY, we know acceleration, we need time to find y, don't we? So let's find the time when x is 2,500, because that's what we're looking for. We're looking to find out the y value, or the height, when x is 2,500. So let's find the time when x is 2,500 and plug that in over here to find the y value. Because look, in the x direction, we now know x is 2,500. We know that Vix is some number, which is 250 cosine 75 from earlier. That value has not changed. So let's go ahead and find the time here. And if we know that time, then we know that time corresponds to 2,500 for x, which also corresponds to what we're looking for in the y direction. So because we can't use the x value directly in here, when x is 2,500, we can't use that to find y. But we can use that to find t, our linking variable, and then use t to find the y value, or the height of the missile, when x is 2,500. Okay? So we're finding time first, and then linking it over. That's why you learn the chain rule in math. Remember the transitive property?
Yeah.
Oh, please tell me yes.
Yes.
In geometry?
Yes.
If A equals B and B equals C, then... Okay, that's what this is saying. If X can... The law of syllogism, sure. If X can be plugged into this equation to get T, and then inherently T gives us Y, then X is really giving us Y. You follow what I'm saying now? Okay? So go ahead and plug 2500 in for X. Find the time it takes. Plug the time in over here with VIY, with AY, and find the Y value. Go ahead and do it real quick. And tell me if this indeed clears the island. If not, where does it hit on the island? So we had a question over here.
Oh, I was just going to answer the question.
Oh, that's what you're going to do? Okay. I didn't know if you had a question. I thought I didn't want to interrupt the train of thought because everybody was focused.
Participate to the...
Thank you. Appreciate that.
Are you saying that we should use that formula, but instead of like,
You should use X and VIX in some formula that you know.
not like the X
To
equals
find-
VI over T or something?
Yeah, there you go. That's a good one. VIX equals X over T. Use that. And you can find the time. Why can you use that in the X direction?
Because we always
Okay, why else? What's the acceleration in the X direction always?
0.
Yeah, when acceleration is 0, you're always going to use VIX equals X over T. So just because you used it already earlier, doesn't mean you can't use it again in a new situation. Okay? Again, use your VIX equals X over T, get your time, plug that into the Y direction, and solve. So I'll write a starting point if anybody's confused. Find this, plug it in there, plug it in there. Let's ultimately find this. Again, you know VIY. You know acceleration in the Y.
Wait, what's DIY? 0, right?
VIY is not 0. It's 250 times the sine of 75.
Oh.
Please remember that, guys. VIY is the same as VIX. Instead of cosine, though, you use sine. Are you guys getting this? Because I don't see you writing. I'm just making sure. So why don't you get a piece of paper out, man? Come on. Okay, but writing it would help when you study. Well, you know what? If everybody hands in the problem set, you'll see the solution anyway. This is the problem set question?
Yeah.
After this problem, I'm going to go over the format of the test, okay? I'm going to talk about the type problems to expect. We'll maybe take another question or two. But I'm glad that we spent time on this problem because if you can really understand what we're talking about, this is the kind of thing you need to do every time. And the problem will vary a little bit, but this is the kind of thought process you want to have. So I'm trying to train you in that mindset.
The test is on Tuesday?
On Tuesday, yes, sir. It hasn't changed at all. It's always been on Tuesday. Listen, if you're not here on Tuesday, you guys are all here Wednesday, Thursday, Friday. So you're making up that test after school one day or before school one day that week. You're not waiting until the following week. So if you're not here on Tuesday, you better email me. For those of you that have extended time that can really utilize it, you better email me some point this weekend. Preferably today would be better. Look at my schedule for next week on Tuesday. Find a time during the day that we both have in common that you can come in to take your extended 22 minutes or whatever it'll be. Okay? What do you get for an answer? Time first. Time first.
Time is 38.6.
Does everybody else agree?
38.7, I got 38.16. It's 38.6.
All right, we'll say 6 or 7, whatever. I don't care right now. What do you get for Y?
2013.6.
Can others verify that, please?
Pop it in.
Anybody verify? To solve for time, you multiply by time, which makes it T VIX equals X, and then divide by VIX. So it's X over VIX. 2,500 over 250 cosine 75. Did you put your 250 cosine 75 in parentheses? If you didn't, it's not going to work. Look at the board. Double parentheses. It's possible you're right, that it's not 38.6. Okay, it is? Okay. All right, so look, guys, let me do it if we're all confused. Real quick.
Wait, what are we looking for?
We're going to find y. So remember this was the equation. All right, take a look. y equals 250 sine 75, that's VIY, times the time, which was 38.6, plus 1/2 negative 9.81 times 38.6 squared. That's what you get for y, okay? I hope it's 2013, which is what I got from the first person. Let's see if it's correct.
I got something different, but.
What'd you get?
No, not negative. It's just,
2013 makes sense because the height of the mountain was 1800. So this means it would have cleared the mountain by 300 meters, right? By 300 meters. 2013 is exactly the right answer. The book gives a height clearance of 210 meters. And that's what it is. 210 meters on top of 1800 would be 2010. You guys said 2013? Somebody said that a moment ago? It's right. It should be 2013. If you're not getting this, you need to really check your calculator. Check your mode. Everybody hit mode right now. Does it say radian or degree?
Degree.
Oh. Let down. If it said radian, that would have been the problem. All right. Let's go over the format of the test. So, there we go. Part 1 is what? Who remembers the last test? Multiple choice. That will be between 30 and 40 points on the test. Okay? Each problem worth maybe 3 points. There'll be 10 of them or so. Okay? No Scantron. Then after that, it's going to be short answer. And that's usually around 30 points. Yeah, that was never really 40 points. And then the last part is, the toughest part I think sometimes. Yeah, free response or mathematical. And that's between 30 and 40 points also. Total 100 points. Now, you have section 2-3, which we didn't even look at today. Section 2-3 on the test was when an object is thrown straight up and straight down, or an object is dropped. What's VIY, everybody?
0.
0. Remember, when an object is dropped, VI is 0. If it's thrown straight up, and you want to find the time it takes to get back down to the ground, what is Y?
0.
0. If I throw it up and it comes straight back down, you want to find the time, just set Y equal to 0. If you want to find the time to get to max height, I'm going over facts. Time to get to max height, VF at the top is?
0.
Yeah, because what happens at the top? So all you do is set VF equal to 0, and you can find the time to max height using VF equals VI plus AT.
V 0, you said?
If you're launching it straight up and you want to find the time to max height, you know VI, say VI is like 20 because you're launching it.
Okay.
You set VF equal to 0, and VF is when it stops.
Okay.
And that's the time it will take to get to max height.
Okay.
Using VF equals VI plus AT, because you have all
Okay,
those.
yeah, that matters.
Okay? If you wanted to think about things being launched horizontally, when they're launched horizontally, what is theta? What's theta here? Give me a number. What's theta here? 30. What's theta here? And then theta when I get horizontal is?
0.
And if you used your cosine of 0, you would get 1. So all the value is in the x direction because it's cosine 0 for x. But what do you use for the y component of velocity? Sine, right? Sine of 0 is actually 0. That's why VIY is 0 for horizontally fired objects. Remember, for horizontally fired objects, VIX is constant the whole way. Whatever it is, 25, 30, it's 25. It's not 25 cosine anything. It's just 25. But the VIY is 0 when it's launched horizontally. We did that example with the tennis ball. If they fall off the table and you drop it at the same time, it should theoretically hit the ground at the same time.
Are you going to give us the equations?
You get the standard equations. They're on Moodle. You know this. Don't ask questions you know the answer to. It's not changing all year. I told you the first day of school, I told you 10 times. You get the same formula sheet all year, you should have already downloaded it. So, you know that, please. What else? Other questions about the format of the test, type of questions? Be careful on the multiple choice, please. Read all the choices before you make a decision. Remember, when is acceleration equal to 0? When you have a constant velocity. That term always comes up over and over again. Please keep that in mind. If an object comes to rest, that means VF is?
0.
If an object starts at rest, it means VI is?
0.
Okay, those are terms you need to know. That's how you break down the word problems. Trying to think of other things to give you hints on. Yeah?
No, do you just know if Tuesday's an A-Day or not? Right?
There's no soccer on Tuesday. Are there any other sports people know about on Tuesday?
No,
Oh no, because it's Kairos. So there's not going to be sports. There might be JV soccer though. Anybody know about JV soccer on Tuesday?
I'll check the calendar.
No, they're.
Okay. So it should be an A day. I don't know off the top of my head, Luke.
Wait, did they?
Okay.
Yeah, so do we
They're
get-
not really good.
Okay. So let's assume it's an A day for now.
Do we have that,
I hope it's not a B day for Kairos. I could see that being a possibility. So seniors leave earlier because they have to get on a bus or a van or whatever they travel.
do you have that, 3-point question at the end, like the little questions?
Probably not. I don't usually do that every test because it gets older. Maybe I'll give like a different kind of question for 3 points at the end.
Yeah, we used to.
Do we have any extra credit for value? Nice picture.